All right, welcome back. And previous video, we looked through this, or in the previous videos, and then we also did this, mnemonics for type 1 error, mnemonics for type 2 error, and simplified mnemonics. And then this is our vocabulary from chapter 8, or that we've been learning throughout the entire course. Now we're going to talk about developing null and alternative hypotheses. And so this is how the textbook presents it. And just got to take a breath. This is how the textbook presents it. And pretty much we've learned everything. Yeah, no, pretty much. We've learned everything we need to know about hypotheses. And so we've got like a type 1 error is that reality is what reality is and you reject it, right? So the null hypothesis, nothing has changed, current state, no change, status quo, that's true, but you reject that and you say, no, actually, things are different. That's a type 1 error. And so it's one person stepping out of line and saying things are different when actually they aren't. And then when two people, when everything has changed and there's still two people holding on to the way it was, that's a type 2 error. And so here, the null hypothesis that nothing has changed, current state, there's no change, status quo, that's false. Things have changed. And then there's two people who are saying, no, nothing has changed. It's still the way it is. That's a type 2 error. I like those mnemonic devices. And so that's what we list here, if you want to pause the video and read through that. And that's also what we list here, those mnemonics. And you can look up this word if you don't know that. But a mnemonic is a little device to help you remember stuff. And then here's the other vocabulary we've been learning. And I think I'll make this yellow because it's important. And we'll make all that yellow. So we got to go to this one to make it all yellow. All right, I don't know. That looked kind of cool with just part of it like that. I like it better that way. All right, here we go. So this is how the textbook presents it, and it's going to be a review of what we already know and have learned right here. And this is the simple way and the total thing you need to know. We've already got that, but I feel a sense of curiosity, maybe even morbid curiosity, like, just to see how poorly the textbook describes what we already learned right here. So let's check it out. And maybe we'll deepen our knowledge a little bit in the process. Hypothesis testing can be used to determine whether a statement about the value of a population parameter, so value of a population parameter, the mean, the standard deviation, the proportion, so we have a hypothesis and can be used to determine whether or not a statement about the value of a population parameter, the population mean, population proportion, should or should not be rejected. The null, so you'd say things like, the null hypothesis, the current state of things is that 18% of the people in California ski, right? And that's a proportion, it's a population parameter, and it's a statement, it's an hypothesis, and we could test that hypothesis, that null hypothesis, the null being the current state, the status quo. We could test that to see whether or not it should or should not be rejected. And should not be rejected means that's true, and should be rejected means that, actually, no, 18% of people, that's not correct. It should be rejected, right? 18% of people ski. So the null hypothesis denoted by H subscript not 0 is a tentative assumption about a population parameter. The null is, this is from our notes earlier, nothing has changed, current state, no change, status quo, right? So we got that from, I don't know, right there. That's where I first introduced this because that helps me remember it. The alternative hypothesis, denoted by H subscript A, is the opposite of what is stated in the null hypothesis. The alternative is that things have changed, there's a new state, there's change. So null, here's another little way to say it, no change, alternative, change. And sometimes the symbol delta is used to represent change. And so delta as change, right? And that's it right here, okay? So delta as change, and it means change or the change. So, if we really wanted to be obscure, we could do no delta, delta, and that just confuses people, so why? It is not always obvious how the null and alternative hypothesis should be formulated. Whatever. It's obvious to me. It's right here. Care must be taken to, the null the hypothesis is going to be the status quo. Nothing has changed. There's no change. And the alternative is things have changed. There's a new state. There's no change. But the book says it's not always obvious because people struggle with this in statistics if it hasn't been explained well. But you're not going to struggle with it because you got it. I explained it well, but that's why they're saying it's not always obvious. It's not always obvious if it's not explained well. And I put this in here. Care must be taken to structure the hypotheses appropriately so that the test conclusion provides the information the researcher wants. The context of the situation is very important in determining how the hypotheses should be stated. Okay, whatever. In some cases, it is easier to identify the alternative hypotheses first. In other cases, the null is easier. Whatever. Correct hypothesis formulation will take practice. All you got to remember is null. The null hypothesis is the current state. It's the status quo. Nothing's changed. There's no change. And the alternative hypothesis is that things have changed. There's a new state. There is change. And that is like everything I've ever seen about statistics in 2 whole semesters that I've taught it. This is actually the 2nd semester. So here's the short summary. The null hypothesis, no change. The alternative hypothesis, there's change. And that's my slide, not the textbook slide. The alternative hypothesis as a research hypothesis. Many applications of hypothesis testing involve an attempt to gather evidence in support of a research hypothesis. Make the alternative hypothesis the desired conclusion. It is often best to begin with the alternative hypothesis and to make it the conclusion the researcher hopes to support. And so if we go get this here, I'm just going to grab that again, right? Because that's really saying what we already know. So I need to do Control C on that. And then I'm going to come here and go there and then just put this in like that. And then I'll bring these over just a touch. Boom, boom. And so many applications of hypothesis testing involve an attempt to gather evidence in support of a research hypothesis. And I'm going to put that in the next level down. Boom, and we'll put it here. There. Make the alternative hypothesis the desired conclusion. Desired conclusion, right? Things have changed. There's a new state. There's change. It is often best to begin with the alternative hypothesis and make it the conclusion the researcher hopes to support, right? So researchers are often looking to support like, hey, something's new, it's changed, it's different than the status quo and the way things have been. So here it is, right? There's something new, it's changed. This is the new drug and these are the better results. So if the alternative hypothesis is true, then the null hypothesis is rejected. That's obvious. Examples, alternative hypothesis as a research hypothesis. A new teaching method is believed to be better than the current method. Alternative hypothesis, new method is better. Null hypothesis, new better is no better. New method is no better, right? New method is better is alternative. New method is no better is null. So null is no change, it's no better. Alternative is the new one. New, right? New, right? New. That's all. That's change. It's new. Alternative hypothesis, another example, is a research hypothesis. A new sales force, new, right? So when you see new, you're thinking already it's new, it's change, it's something different, it's alternative. So alternative hypothesis is new bonus increases sales. Null hypothesis is new bonus does not increase sales. So the null hypothesis is that there's no change, right? Nothing changed. Here's another one. A new drug, new drug, new drug, new drug. Lowers blood pressure more than the existing drug. Alternative hypothesis, the new drug lowers blood pressure more than the existing drug. The null hypothesis is the new drug does not lower blood pressure more than the existing drug. So the null is that there's no change, right? Nothing changed. The new one's no better than the old, there's no change. The alternative is that, hey, it's new, there's change. So null hypothesis is an assumption to be challenged. We might begin with an assumption, and this is just a reminder right here, right? Boop. Oh, but it brings it all the way in, so I won't do that. We might begin with an assumption. I wonder if I do this, if I do this, if I do this, and then do this. Does that bring it all over? Trick in the computer. There we go. We might begin with an assumption that a population parameter is true. Population parameter, so we'll just highlight that. It's like, phrase. I like highlighting phrases. population parameter, the mean, the proportion. We might have this assumption that the population parameter is true. We then use a hypothesis test to challenge the assumption and determine if there is statistical evidence to conclude that the assumption is incorrect. In these situations, it's helpful to develop the null hypothesis first. All right, whatever. Null hypothesis as an assumption to be challenged. I don't know why that's on 2 rows. Oh, because I moved it over like that. All right, that makes sense. I wonder if I could put that into, I'm just thinking about this, like copy this. I'm going to copy all this. Copy all that, and then put it here, and then just put it right back. And find the location there, about like that. And then in this one, whoops, in this one, we'll delete all this. Whoop. And now we'll move this one up. Whoop. And then we'll click this one. And in this one, we'll delete all that and then just bring it back down. And we can bring this down a little bit and bring this up, bring this up, bring this up. Boop, boop, boop. I think that did what I was hoping for it to do. We'll see. And bring this down. Bring it up. There we go. And then bring this one over. And it's kind of silly having all this stuff down here by itself now. So I'm going to grab all that and bring it up. Null hypothesis as an assumption to be challenged. Seems like I lost something in that slide. I don't think I did though. We could do Control Z and just like go all the way back. And this is what it looked like before. Example. Oh, we lost the example. All right, so we're going to copy that and then just redo everything. That's cool. And then I got to hit here and paste in that example part. And then before I do that, I'll grab these and bring them down. Oh, I don't want all of that. So we're going to bring this up. And I'll grab these and bring them down. I'm sorry, I know this is a little bit tedious. But maybe you're learning some presentation skills. You're seeing how I work. And that can be edifying. And edifying means that it teaches you. And then I'll bring that up. There we go. So the null hypothesis is an assumption to be challenged. Example, the label on, I like it better if it be like this. Whoop, like that. The label on a soft drink bottle states that it contains 67.6 fluid ounces. So the null hypothesis, the label is correct. You've got at least, and so again, remember, if label is correct, let's get this. And I'm just going to like, can I just paste it? And it puts it, oh good, it put it into a box. There we go. And we'll bring this down here and just do this as a reminder. There we go. So, and then we'll group this stuff a little bit more closely and tightly up here. There we go. That kind of puts it together. Maybe not quite that high. All right. Example, label on a soft drink bottle states that it contains 67.6 fluid ounces. So the null hypothesis is that the label is correct, right? This is the current state. It's the status quo. Status quo. If you look up status quo, it's Latin for the way things are right now. The existing state of affairs, especially regarding social or political issues. So this is the status quo. The label's correct, right? The bottle has, the population mean is 67.6 ounces. That's what the bottle's got. So that's the null hypothesis, right? Nothing's changed. Current state, the bottle, the population mean has at least 67.6 fluid ounces or more. Because you got to think about it logically. If your label's saying this has 67.6 fluid ounces and you get like 70 ounces, you're happy as a consumer, as a customer. But if it says you get 67.6 fluid ounces, but you keep getting 51, you keep ordering, right? Like you get 51, you're not getting what you're paying for. And now you're not happy. So the current state is the status quo. There's no change. Nothing's changed. The bottle claims to have at least 67.6 fluid ounces, claims to have this, and you're getting that, at least that or more. That's the null hypothesis. It's the current state, status quo, no change. The alternative hypothesis is that even though the label says that, that's incorrect. and you're actually getting less than that. There's a new state. There's been a change. Things have changed. The label says this. This is what they maybe intended, right? Or this is what they presented they intended. And actually they're delivering less than that. So there's been a change from what was presented. So that's those are those two hypotheses. The equality part of the hypothesis always appears in the null hypothesis, right? So equality is always going to be in the null. I haven't really thought of that one all the way through. I'm just going to say that's the people who got their PhDs in statistics understand why the equality part should always be the null. Maybe if you just think about that from a logical standpoint, like, I don't know, it's like you're always testing stuff where it's equal to or greater than or completely equal to, and that's the current state, and the change is that it's not that. But anyhow, this is something you could just take on face value and remember. The quality part of the hypothesis always appears in the null hypothesis, and maybe that's just the no change part of it. It logically will show up in the no change. So in general, a hypothesis test about the value of a population mean, let's highlight that. We got a little phrase there, population mean, and the hypothesis test, that's a little phrase right there, we'll highlight that. The hypothesis test about the value of a population mean must take one of the following three forms, where U naught is the hypothesized value of the population mean. So the null hypothesis is that the hypothesized value of the population mean is greater than the hypothesized value. So here, greater than or equal, that'd be a lower tail test, upper tail test, and a two-tail test. This is going to become more clear as we do some problems. This is one of the things, the way the textbook presents it, which I think is confusing, so don't stress on that. I've looked at it several times. It still kind of confuses me. But when you do the problems, you're like, that makes sense when you actually work through the problems. But when you try to memorize that stuff, for me at least, it's just like dumb. All right, so that's developing null and alternative hypotheses. So that's what I'm going to name this video, and I will see you in the next video coming up soon.